In this tutorial, we are going to revise all topics required for the system-wide quiz. You know that the differences in electronegativity lead to different types of bonding. So, if the difference in electronegativity is between 0 to 0.4, the bond is considered nonpolar. While if it was more than 0.4 until 1.7, we consider the bond polar, and more than 1.7, we consider the bond ionic. Remember the trend of electronegativity, that the electronegativity increases as we go from left to right, and also increases as we go from down upward. This means that the highest electronegative elements will be existing on that side of the periodic table, while the elements at the bottom of the periodic table and the left-hand side, they have very low values of electronegativity. So, if you have a question like this, asking which of the following bonds would be most polar, you are going to look for the values, calculate the differences in electronegativity, and then take your choice. In this example, I'm not going to give you the values of electronegativity. We need just to look at the position of the element in the periodic table and decide which of them is the most polar. Looking at CO, you can see that both of carbon and oxygen are very close in the periodic table, means that they have very close values of electronegativity, and this suggests that the molecule will not be polar or it will not be very high polar. Comparing to HO, hydrogen is in group 1, oxygen is in group 6. Okay, we are expecting that they are very far away, means that we are expecting that the value difference in electronegativity is very high, but not as high as the difference between H and F. Okay, because we said that the element at the top right side has very high value of electronegativity. And fluorine is the most electronegative element. It has the highest value of electronegativity in all the periodic table. So we are expecting that HF will be the most polar one. Which of the following molecules has tetrahedral shape? Tetrahedral shape means that you should first recognize the type of hybridization. Tetrahedral means the hybridization is sp3, and in sp3 hybridization, the central atom is surrounded with 4 other atoms. So we are expecting that the molecule must be CH4. CH4, it has tetrahedral shape. The central atom needs to have 4 bonds and no unbonded electron pairs. Only CH4 has 4 bonds with no unbonded or lone pairs. Which hybridization would best represent the oxygen atom in the following molecule? By looking at the oxygen atom, you will recognize that O is surrounded with 4 effective pairs. 1, 2, 3, 4. If we have 4 effective pairs, this means that the central atom should be surrounded with 4 orbitals. So the hybridization should be sp3. To be able to answer this question, which hybridization would best represent oxygen in the following molecule, we said that it should be sp3 because the central atom is surrounded with 4 effective pairs of electrons. While here, which of the following molecules has polar bond, but it is nonpolar molecule? I told you before we might have polar bond if the electronegativity differences between the two atoms is more than 0.4 and less than 1.7. But to make a molecule polar, so the molecule should have a net dipole, and this happens only if the molecule has lone pairs of electrons. So very simply, you're going to choose one which is polar. So we are going to ignore O2 because the difference in electronegativity here will be 0. NH3, it has lone pair, so it should be polar. HF, it has lone pairs, it should be polar. This molecule also, it has oxygen O, so it should be polar molecule. While CCl4 is just central carbon atom surrounded with 4 Cl atoms. It doesn't have any lone pair, and all dipoles cancel out, so the molecule is nonpolar, although the bond CCl is a polar bond. You can see here, if you draw the dipoles of the molecules, all the dipoles will cancel out. Dipoles are going to cancel out, resulting in a dipole moment. We call it 0, or the dipole moments cancel out. So this molecule is nonpolar. So to summarize, the effect of VSEPR with hybridization, remember that if we have a formula AX2, AX2 means the central atom and surrounded with 2 other atoms. The type of hybridization here is 2 because the number of effective pairs, remember, number of effective pairs are 2. If the central atom surrounded with 2 atoms, so the effective pairs are 2. In this case, the molecule should be linear, the angle is 180, and hybridization is of the type SP. And of course, it will be nonpolar. Why it's nonpolar? Because the dipoles are going to cancel out. They are equal and opposite and on the same line, so they are going to cancel out, and we have some examples here. While if the central atom surrounded with 3 other atoms, we are expecting that the hybridization, which is made of 3 effective pairs, should be AX of the type sp2, and the angle is 120. The shape of the molecule will be trigonal planar. Also, it will be nonpolar because the dipoles are going to cancel out. The examples here, BF3, BH3, SO3, and so on. If the hybridization of the type sp2, here we have central atom surrounded with 3 effective pairs, so the hybridization should be sp2. But this molecule has 1 lone pair. Presence of the lone pair will make the molecule polar and is going to change the shape of the molecule from trigonal planar as expected into V shape or band shape or angular, and the angle will be 104.5 and not 120. We have some examples here, SeO2, SO2, and O3. This one should be AX2E, just 1 lone pair. If AX4 means the effective pairs are 4, or there are 4 pairs of electrons around the central atom with no any lone pair, the type of hybridization will be sp3 because 1s with 3p are hybridized. The molecule will be tetrahedral, the angle 109.5. Because there are no lone pairs, dipoles are going to cancel out, resulting in a nonpolar molecule. We have examples that we have done them so many times before: methane, CH4, CCl4, SiF4. AX3E. AX3E means the central atom surrounded with 3 other atoms, and there is 1 lone pair. Presence of the lone pair is going to change the shape of the molecule from the expected shape, which is tetrahedral, into pyramidal shape. trigonal pyramidal, making the angle less than 109, or you can say it's 107. The molecule will be polar because the dipoles will not cancel out, and we have examples like NH3 or PH3 or PCl3. In this structure, the central atom surrounded with 4 effective pairs, so the number of effective pairs are 4, and the type of hybridization will be sp3. And according to electron domain geometry, we are expecting that the molecule will be tetrahedral with an angle 109.5. But presence of 2 lone pairs are going to repel each other the most and push the bonding pair to one side. So the bonding pair are going to make an angle 104.5, and the molecule will be V-shaped or bent, and of course it will be polar because the dipoles will not cancel. We have many examples here. The most famous one is H2O and H2S. In case of AX5, central atom surrounded with 5, so the molecule will be trigonal bipyramidal if there are no lone pairs, with angle of 90 and 120. The type of hybridization, as there are 5 effective pairs, so we have 1s, 3p, and 1d, making a hybridization of sp3d. It's nonpolar because the dipoles are cancelled. The example, you can say PCl5 or ASF5. While in this kind of hybridization, where the central atom is surrounded with 5 effective pairs, but one of them is a lone pair. Presence of the lone pair is going to push the other bonding pair closer, changing the angle, so the angle will be less than 90 and less than 120. This molecule is called seashore or sawhorse. Of course, it will be polar due to presence of the lone pair and because the dipoles are not cancelled out, or you can say there is a net dipole moment. Example is SL4 or SF4. You are asked in an exam, if you have given those examples and you will be asked is the molecule polar or not and what is the type of hybridization, okay, let's practice. Let's take for example SCl4. S, sulfur, is in group 6. This means that it is surrounded with 3 pairs of electrons. And Cl4, so this means that sulfur is going to make 4 bonds with 4 Cl atoms. And because sulfur is surrounded with 6 electrons and it shares 4 electrons with 4 Cl atoms, so sulfur will have 1 lone pair. By looking at a molecule like this, you should recognize the type of hybridization because I have 5 effective pairs, 1, 2, 3, 4, and 5. So the hybridization will be sp3d. The shape of molecule look like seesaw. If you don't know if it's seesaw or not, at least you will be able to say that it is not trigonal bipyramid. And it will be polar because the dipoles will not cancel, and this is due to the presence of the lone pair of electrons. Here, it's AX3E2, mean the central atom surrounded with 3 other atoms, X3, and E2, 2 lone pair of electrons. The molecule will be T-shaped. Type of hybridization is 1, 2, 3, 4, 5. So DSP3. It will be polar because the dipoles will not cancel. Okay, and the molecule will not be trigonal bipyramid, and instead it will be a T shape. In this kind of molecule, AX2E3 mean the central atom surrounded with 2 other atoms, and we have 3 lone pairs. The lone pairs, they are going to orient themselves like that, making the molecule linear. Okay, and the type of hybridization will be according to the number of effective pairs 1, 2, 3, 4, 5, so DS3P. It will be nonpolar because the dipoles are cancelled, because we have opposite dipoles. If we have opposite dipoles, dipoles should cancel out. AX6, it's 6 effective pairs around the central atom. So the type of hybridization will be S3P and 2D, making sp3d2. The molecule is octahedral with a bond angle 90 degrees. It will be nonpolar because all dipoles should cancel out. We have examples like SF6 or PCl6 are very famous ones. This molecule looks similar to the first one, but instead it has one lone pair. Presence of the lone pair will little bit change the shape of the molecule, making all the bonding pair closer, and the angles will be less than 90 degrees, and the molecule should be polar finally. In this example, AX4E2. So central atom A surrounded with 4X and E2. We have two lone pair of electrons. So they will make a shape that we call it a square planar. The angles are 90 degrees and it will be nonpolar because you can recognize and expect that the dipoles are going to cancel out. We have opposite dipoles in all directions, so they are going to cancel out. This slide shows you the formation of hybrid orbitals. For example, sp3 hybrid orbital. sp3 results from hybridization of 1s with 3p orbitals. So if s orbital get mixed with px, py, and pz, they are going to form 4 new orbitals. Each of them is sp3. They are going to orient themselves in that way, forming a tetrahedral structure with angle 109.5 between bonds. While this slide shows you the sp2 hybrid orbitals. sp2 results from a mixing of s orbital with 2p orbitals like px and py, resulting in 3 new orbitals because the number of hybrid orbitals should equal the number of atomic orbitals before hybridization. Just the name and shape will be changed, but the number shouldn't change. So the new orbitals, we call them sp2. They form trigonal planar with angle 120. Let's practice this question. This question is about resonance. Determine the molecular geometry of NO3. If you have a question like this, you should first count the number of electrons around the central atom and the number of electrons in the whole molecule, NO3, and remember that it has minus, means it has one more electron. So NO3, N has 5 electrons in the outer shell, each oxygen has 6, 6 multiplied 3 equal 18, plus 1. This one is this charge, minus. So the overall number of electrons are 24. So draw Lewis structure first and then recognize the resonance forms for it. So I will draw nitrogen atom. Now nitrogen is in group 5 and has 5 electrons, and there are 3 O, means that nitrogen is going to share electrons with oxygen. How many electrons does it share here? 1, 2, 3, 4. Remember that the whole molecule has a negative charge. And then you need to complete the drawing by adding the rest of electrons. Oxygen has 6 electrons in outer shell. It shares 2 electrons here, so 2 pairs are remaining, while the ones who make single bond will have 6 electrons. Do that all the time. If single bond, draw 6 electrons. If double bond around oxygen, draw 4 electrons or 2 pairs. If you have a shape like this, you can recognize that you will be able to draw more than one resonance form. I can draw 2 more by changing the position of the double bond. If you put the double bond here or there, so you will have 2 new structures. These are all the possible forms for nitrate ion. What is finally the molecular geometry of the molecule? This is resonance structure. Resonance structure does not show the geometry. Geometry should show the three-shape structure. You have nitrogen atom, here no lone pair, so I just have 3 effective pairs. We have 3 effective pairs around the central atoms. So N will make 3 bonds like this. We can expect that the molecule should be trigonal planar and the angle should be 120. Type of hybridization, again, what will be the type of hybridization here? Okay, you need to count only the effective pair and remember that the double bond is counted as 1. So 1, 2, 3 effective pairs. If I have 3 effective pairs, the type of hybridization will be sp2. sp2. This slide explains the effect of the lone pairs on molecular geometry. Remember that the maximum repulsion is if we have 2 lone pairs, and the minimum repulsion is between bond pair and bond pair. In CH4 molecule, no lone pairs, so the bond angle is 109. The molecular geometry is tetrahedral, like the electron domains geometry. In ammonia molecule, ammonia has 1 lone pair. Presence of the lone pair is going to push the bond pair, bringing them closer, because the bond pair and bond pair have the minimum repulsion, decreasing the angle into 107 and changing the molecular geometry into trigonal pyramid. Trigonal pyramid. While presence of 2 lone pair, like in water, they are going to push the OH bond closer. The bond here is 104, which is less than 107 here, and the shape of the molecule is bent or V shape. Remember this table depends on the number of effective pairs or the electron groups and the number of lone pair. The molecular geometry will be altered. Presence of 4 electron pairs and one of them is a lone pair, making the geometry trigonal pyramidal, like in ammonia. Presence of 4 effective pairs, 2 of them are lone pair, making the molecule bent like in water, and so on. Now let's practice questions. Determine the molecular geometry of CCl4. Very simply, you are going to draw the molecule, the geometry of the molecule, show the bond angle, and write the molecular geometry, tetrahedral. Question 2. In determining electron geometry, why do we consider only electron groups on the central atom? In other words, why don't we consider electron groups on the terminal atoms? The central atom is surrounded by electron groups. The number of the electron groups surrounding the central atom determine the geometry of the molecule because they are going to orient themselves around the central atom, giving the geometry of the whole molecule. Question 3. What is the geometry of HCN molecule? And he gave you the Lewis structure of HCN. Any molecule which is made of just 3 atoms, central 1 and 2 on terminals with no any lone pair, the molecule will be linear. How can we know there is lone pair or not? Count the number of electrons. Carbon has 4 electrons around it, and you can see that there are 4 bonds around the carbon atom. While in this question, suppose that a molecule with 6 electron groups were confined to 2-dimensional and therefore had hexagonal planar geometry. If 2 of the 6 groups were lone pair, where would they are located? So if 2 from those 6 groups were lone pair, where they will be located? Yeah, that's true. They will be in position 1 and 4 because, as you know, the highest repulsion is between lone pairs and the lone pairs. Question 5. Which statement is always true according to VSEPR? You can see that according to VSEPR, the geometry of the molecule is mainly determined by the repulsion between all the electron groups around the central atom. You should mention the central atom in your answer. For each molecular geometry, list the number of total electron groups, number of bonding groups, number of lone pairs on the central atom. Looking at this molecule, it's very clear to you to say that the central atom surrounded with 4 atoms, so it is of the type AX4. The number of total electron groups around the central atom are 4. Number of bonding groups, they are 4 because there are no lone pairs. Number of lone pairs, 0. Here, if the molecule orients itself in this shape, so the molecule should has lone pair of electrons. So I will say that the number of total electron groups are also 4, even if this one is not clear, but it should be here, because otherwise the molecule will be trigonal planar, and it is not trigonal planar. Number of bonding groups are 3 and 1 lone pair. Here, 1, 2, 3, 4, 5, so 5 effective pairs. All of them are bonding with 0 lone pair. This molecule is of the type A, 1, 2, 3, 4, 5, 6 of type AX6. So the shape of the molecule will be octahedral with angle 90 degrees. It doesn't have any lone pair. It has 6 effective pair and 0 lone pair. While this molecule, it seems that it has central atom surrounded with 4 other atoms. But in order for the molecule to take this shape, there should be 2 lone pair on either side. So the molecule will be of the type AX4E2. The number of effective pairs, 1, 2, 3, 4, 5, 6. There are 4 bond pair and 2 lone pair. This molecule also should have a lone pair here in order to make all the bonds like that. This is the seesaw structure. The number of effective pairs are 1, 2, 3, 4, 5. 4 of them are bond pair and 1 lone pair. To answer this question, you are asked here to fill the table about the molecular geometry and the bond angle. you should keep the periodic table next to you and try to draw the molecules. Be, beryllium, is in group 2, so we have Be, we'll draw here. Be is the central atom, and 2 Cl atom on either side. No lone pair because it does have only 2 electrons in the outer shell. The bond angle will be 180. The molecule will be linear. Type of hybridization, because we have only 2 effective pairs, so type of hybridization will be sp, and the dipoles are going to cancel, so the molecule is said to be non-polar. While in this example, BF3, B boron is in group 3, so it's surrounded with 3 F atoms. It shares all its electrons, meaning that the bond angle will be 120 and the molecule will be trigonal, planar. The bond angles are type of hybridization is sp2 because I have 3 effective pairs. It will be nonpolar because the dipoles will cancel. Why they will be cancelled? Very simply because there are no lone pairs of electrons. CH4 is tetrahedral, you know it well. The bond angle is 109.5. Here the central atom surrounded with other 4. The type of hybridization where we have 4 around the central atom will be of the type 1, 2, 3, 4 of the type sp3, and as the dipoles will cancel, so it's a nonpolar. SiF4, silicon is in group 4, so it will be very similar to CH4. PCl5, phosphorus is in group 5, surrounded with 5 electrons. It's going to share these 5 electrons with 5 Cl atoms. So the molecule will be trigonal by pyramid. Okay, we can write it bipyramidal. The bond angles will be 90 and 120 degree. Type of hybridization, count the effective pair, 1, 2, 3, 4, 5. So it's type sp3d, and it will be nonpolar. SF6, sulfur is in group 6. Yes, that's true. Okay, it's in group 6. So S surrounded with 6 F. sp3d2, and it will be nonpolar because the dipoles will cancel out, or no net dipole. Angles are 90 degree and the shape of molecule is octahedral. SeCl6, selenium, locates in group 6 in the periodic table. So it will be also very similar to CF6. We'll practice here some more examples, and I will leave the rest to be done for you as a practice. SO2. Sulfur, also in group 6, 6 electron outer shell, is going to share 2 electrons with each of the oxygen atom, leaving 1 lone pair. So the molecule will be bent, and the type of hybridization will be sp or sp2, sp2, the angle will not be 120 due to the presence of the lone pair. Also, if you go to PCl5, PCl3, see the central phosphorus atom. It has 5 electrons in outer shell. It shares 3 electrons with 3 Cl atoms, leaving 1 lone pair. The molecule will be trigonal pyramid. The hybridization will be 1, 2, 3, 4, so sp3, but the angle will not be 109, it will be actually 107. In the same way, you are going to practice the rest of examples. Question may seem difficult to you, but it's very simple. Here, it's given to you the ball and stick model, and there are some mistakes in the molecular geometry. We need to see what is wrong and correct the molecular geometry. Here, it seems to be of the type AX3E. So it will be tetrahedral, but the tetrahedral will be altered due to the presence of the lone pair, making the molecule, so I have central atom and 3 and 1 lone pair. Okay, sorry, this will be drawn here. Okay, so the bond angle was wrong because the bond angle is not 109. The bond angle should be only 107, and the molecular geometry should be trigonal pyramid. Here, central atom surrounded with 4 and 1 lone pair, so it is the type AX4E. So the normal geometry should be trigonal bipyramid. By presence of 1 lone pair is going to alter the shape. The correct shape of the molecule that we call it seesaw. This, according to what's given here, it's of the type AX4E2. So it's the normal geometry will be octahedral, but it will be altered due to presence of the lone pair. In this case, the lone pair should go as far as possible in space. And this will be the correct geometry of the molecule. In this molecule, we have central atom, okay, surrounded with 2 other atoms, and we have 2 lone pair. They should be like this, and the molecular geometry should be bent, and so on. This part is summarizing what is required for a molecule to be polar. For the molecule to be polar, it should have a dipole, and the dipoles should not cancel. Or we can have a net dipole moment, or you can say the net dipole moment is not equal to 0. Okay, you know how to draw the dipoles. The atom with a small value of electronegativity will be positive, with one higher value of electronegativity will be negative. Draw the partial charge and show the dipole. Some dipoles are strong, some dipoles are weak. Strong and weak depend on the difference in electronegativity. The high difference in electronegativity make the molecule, we can say in the exam, most polar or most ionic or strong dipole. They are all having the same meaning. The difference in electronegativity is small. We can say we have weak dipole. This slide summarizes to you how the dipoles might cancel out. If you have carbon dioxide molecule, okay, with central carbon atom which is partial positive and negative oxygen atom, the dipoles will cancel out because they go in 2 opposite direction. Here also the dipoles will be cancelled. In this case also they will be cancelled. Very simply, to make it easy for you to memorize, in the exam, draw the partial positive and negative, show it, show the direction of the dipoles and make a net dipole in the direction of the forces, because this dipole going up, this one going up, so the net dipole should go up. So the molecule has dipole and the net dipole moment is not equal 0. Finally, the molecule will be polar. In ammonia molecule also, we have a net dipole going up, so it will be a polar molecule. In carbon dioxide, it's a nonpolar. HCl is polar because we have one pole here. In CCl4, dipoles will cancel, so it's nonpolar. In H2S, okay, S is negative, H is positive, dipoles are going up, so the net dipole will go up, the molecule will be polar. ClCl, it's a nonpolar because even the difference in electronegativity is just 0. Okay, so you should be able to draw the diagram with the dipoles for any structure. You should decide if the molecule has dipoles or not. Yes, they all have dipoles, but some of them are polar and some are not polar. This is very important to note for you. Any molecule is nonpolar if it has any of the following 3D structure. If it's linear, trigonal planar, tetrahedral, trigonal bipyramid, octahedral, square planar. All of those are nonpolar, even if they have dipoles. So SCl4, it will be tetrahedral, so it's a nonpolar. BrCl5, it's trigonal bipyramid, so it's nonpolar. SCl2, so it's of the type AX2. No, it is not of that type because S is in group 6. It has 6 electron outer shell. It shares 2 electrons with Cl and it has 2 lone pair. So it's of the type AX2 E2. Okay, this molecule should be polar because it's bent. Okay, now we'll revise again type of hybridization. You should first draw the Lewis structure. Use VSEPR to predict the electron group geometry around each central atom. Use this table to select the type of hybridization. And you know, if we have just 2 atoms around the central, it will be SP and the linear. If there are 3, even if one of them is lone pair, it will be trigonal planar type of hybridization SP2, and don't confuse them. If the type AX4 or one of those X's is replaced with 1 or 2 lone pairs, so it will stay tetrahedral and type of hybridization stay SP3. AX5 or any alternatives, trigonal bipyramidal DSP3. Remember that those are electron geometry and not the molecular geometry, because presence of lone pair will change the molecular geometry. But the type of hybridization is determined only by the electron geometry. If AX6, yeah, octahedral and D2sp3. Remember that if we have sigma and pi bond, if we just have one single bond, it should be sigma. If you have a double bond, 1 sigma and 1 pi, and if you have triple, will be 1 sigma and 2 pi. So like in ethine molecule, if you have a bond like this, and you will be asked how many sigma and how many pi. Very simply, there are 3 bonds, so one of them is sigma and 2 pi. But if you have a molecule with like ethane molecule with a double bond between the carbon atom, one bond will be sigma and the other will be pi. Okay, whereas in methane molecule, because all bonds are single, so all bonds are sigma. Even if you have any other molecule with so many carbon atoms, if they are just single bond, so all single bonds are sigma bond. This question asking about the type of hybridization and the bonding in the following molecules. Let's start with HTN. H, of course, make single bond. C, it should make 4 bonds because carbon is in group 4, and N. N is in group 5. Okay, it shares 3 electrons and still has electron pair around it. But you know, the type of hybridization and the bonding and the geometry only depend on the central atom. So central atom now, it's very clear to you to recognize that the dipoles are going to cancel, so the molecule will be linear and the angle will be 180. In CO2, central carbon atom surrounded with 2 oxygen, okay, the dipoles also are going to cancel, linear, and the angle is 180. As I3 molecule, its central iodine surrounded with 3 other iodine atoms, but it still has 1 lone pair. This make the molecule polar, and the type of hybridization will be 1, 2, 3, 4. So if the type sp3. This question is asking to draw the resonance structure for some molecules like O3 and NO3, and we have discussed it before. The double bond, you are going to change its position, and while you are changing the position, remember to change the number of electrons around oxygen atom. Okay, in the same way, you are going to practice drawing NO3 with changing the position of the double bond. Thank you.